okay? One of them was a project contract, which was basically you and your partners saying, hey, we're going to do some stuff, here's the stuff, here's who's going to do each thing, here's my signature. Seriously, that should take no more than 10 to 15 minutes. It's been due for 8 weeks. If you haven't got that turned in, shame on you. There aren't even wrong answers. Okay? You could have gotten a return to you if you didn't fill anything out, or if you gave me the wrong piece of paper, if you gave me the wrong assignment, if you gave me your project planning sheet, for example. Okay, but that should have been found out 8 weeks ago, and then you should have gone, oh, okay, and turned it in. So that's number one of 5 assignments that were due over the last 8 weeks. 2, a project planning sheet. Again, no wrong answers. If you turn it in blank, we didn't accept it. And if it was super general, like group member Billy's gonna research Newton's first law, Susie's gonna research Newton's second law. Okay, guess what? That was my assignment to you. You're not telling, that's not a plan. You're not telling me anything that you're gonna do for your project. The whole purpose of the project planning sheet is twofold. One, so you can make a plan for what you're going to do, because that's all your points. 2, so I can see, or Mr. House can see, what you're planning to do, and if you're going completely off the wrong direction, we can go, whoa, 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 no, this won't work, this thing you're saying you're going to do. You're fundamentally misunderstanding something. Or I had a group who wants to build a Rube Goldberg device. This is a really cool idea that I would recommend against. There are all sorts of ways that you could demonstrate Newton's laws with a Rube Goldberg. Does everybody know what a Rube Goldberg machine is?
Yeah.
Those weird things where there's the boot that kicks the thing, that makes the thing roll down, that lights the match. Okay. Those were all, there were famous drawings by a guy named Rube Goldberg who invented that stuff. It's a really cool idea. I have seen the Mythbusters try to do one, and they are way more experienced than anybody in this room, including me or House. They have way more resources, and they have lots of practice as props creators making stuff, and I've seen them screw it up a bunch of times. It's really hard to do, and so I would have said, sure, they can try it, it's a neat idea, it's way overkill for this project, and probably they'll end up getting frustrated and not doing it, and that's advice that I would give them. So the project planning sheet, not really a wrong answer, you're telling me what you're going to do, but many of you still haven't done that. Again, maybe 30 minutes? If you really plan out, if you pay attention to what you should have done, and really it should take 15 minutes to fill out after a week of thinking about, hey, what are we going to do? But real actual work on that document, 15 or 20 minutes. Okay? No wrong answers. Third thing of these 5. A rubric in which you are to tell me, hey, this is what this is how what we're going to do is going to fulfill this assignment. I cannot tell you how many people turned in something that was obviously copied and pasted from someone else because I read the same thing over and over and over again, and it was wrong every time. It said something like, I'm going to demonstrate Newton's third law. If you do it in the original way, you get a distinguished. If you copy something we did in class, you get a proficient. That's not filling out the rubric because it does not tell me anything about how you plan to demonstrate it and why you deserve a distinguished based on the thing you're going to do. Again, well, I guess there's sort of a wrong answer there. there's lots of right answers. Then there was things that have right and wrong answers, sort of. Okay, that's 3 out of 5, all of which are really simple, that don't even really have right and wrong answers particularly. There's the scientific nursery rhymes, which we did in class for like 3 days, and was very short. Also, 8 weeks ago, it's the first thing we did. And then there was this. Unpacking this. Most 90-something% of the students in this school have not gotten satisfactory on those 5 things. Also, by the way, you can turn them in. I will tell you what's wrong with it. You can redo it. All over that 8-week period, right? This should have been simple for everyone to have finished. And it is completely absurd that it's not done. I don't know what else to say than that. It's nuts that it's not done.
Mr. Chester, I've noticed that you've not even mentioned yet the fact that we have dedicated huge amounts of class time to all of these projects.
I did on the nursery rhyme thing, but you're right.
I mean, and did models of this, and use the nursery rhymes as a scaffold for this, and let you work in groups for days and days on end to complete this assignment that takes 15 or 20 minutes. It's not even homework. We gave you class time to do all of this. And in my estimation, all 5 of these assignments is probably less than 2 hours work. You've had 6 or 7 weeks to get them complete, and they've been group assignments for the vast majority of you. And in 7 weeks, you can't do 2 hours worth of work. That's a mismanagement of your time and your resources.
This is majorly problematic, guys. You will not continue on to you will continue on to Unit 2, but you can't turn anything in until you get this stuff fulfilled. Which means now that doesn't mean, oh, I'm just going to ignore Unit 2. We're moving on. At the end of this period, I'm moving on. Okay? We're going forward. You're now doing both if you're not done. Because you've got to keep up with this stuff, and you can see it, but you can't turn it in. And you better stay on top of it, because here's what happens, and here's the fundamentally best part about this school, in my opinion. And you can ask House, because he can't count the number of times I've complained about this.
He complains about a lot of things a lot. Oh, sorry, was that not the comment I was supposed to be making?
That was supposed to be in your head, not out.
Oh, sorry, my filter.
In most schools, what would happen if you hadn't done stuff is if you got a 60%, we'd be like, oh, well, they didn't understand any of these things, but we're just going to let them move on and you know, go to the next grade. That's all the schools I've ever taught at. Here's why that's a horrible, 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 horrible disservice to you and what you don't seem to get and what students just don't understand. Okay? Our job, well, he's an administrator now, so my job and his old job,
My old job.
was this. We've gotten pretty good at some stuff, some science stuff. We know some things, like some facts, and we also know some fundamental applications, and we understand some science things. So for example, we understand Newton's third law, which says that when I push this chair, action, the reaction is that the chair slides across the floor, correct? Raise your hand if that's correct, come on. No, wrong! That's not correct! And I've said that a dozen times to you guys. What's the reaction? Say that louder. It pushes back with equal force. How can I possibly fool you all that easily?
Because we're teenagers.
Maybe. So we know some things like about how that stuff works. And the job is this. The stuff in my head, at least part of it, the understanding and the knowledge, I put it into your head. That's my job. This stuff goes in there. You guys act like this is some sort of punishment, okay? This is for you. Taxpayers pay us to do this for you. My job is to get the stuff that I know in there. If I send you off without having done that, I have failed you. If I let you move forward where you might need that stuff someday and you don't have it, I shouldn't have done that. I shouldn't have let you go because I have failed to make sure the fundamental aspects of my job. Okay? In most schools, I would just do that because that's what happens. They make me do that. I've always hated it. I call it failing to fail. For the same reason that I wouldn't take a student who has not the first clue how to swim and lead weights tied to their legs and throw them in the deep end of the pool because they will drown. I should not allow you out of here without knowing the stuff that I am charged with teaching you. And the awesome thing about this school is I don't have to let you move on. And let me tell you what really would happen. And I've seen this over and over, and I can give you statistics about it. We let you go on, and then the next group, the next science class lets you go on, and they let you go on, and they let you go on. You haven't learned nearly all the stuff you're supposed to learn. And you get to where you're thinking, hey, I'm pretty good at this school thing. And you graduate 12th grade, and you go, I'm pretty good at this, I'm going to go to college. You get to college, and college will not pass you, and also, by the way, you're paying them 5 grand, 10 grand, 20 grand, 40 grand, depending on where you go. If you just slip through the cracks, you're probably not paying them 40 grand. But 5 or 10, and guess what? When you fail, they give your money back, right?
No.
No! So here's what I just did. We pushed you along, and we pushed you along, and we let you go past, and we let you go past, and you think, kind of rightly so, oh, well, I made it through. I can probably do college too. 40% of freshmen in college don't make it to sophomore year, the U of A. And part of that is because your schools let you out before they should have. I don't have to do that here. If you don't finish this stuff, if you're still stuck here, guess where you start next year?
There.
Right there. This is not a punishment. I mean, it feels like a punishment, and I get that. But keep in mind my job. My job is to take these things I know, put them in here. And if they're not in there, I shouldn't be letting you go on. Now, here's the thing about that. I'm not a mind reader. He's not a mind reader. Mr. Rollins is not a mind reader. Your parents aren't mind readers. Our bosses at the state are not mind readers. The way we demonstrate that we did our job, that we took that stuff and we put it in there, is we ask you questions that you can only answer if you have some of that knowledge in your head. That's the only reason for tests and stuff, and that's the only reason for these projects, and that's the only reason for the assignments. It's almost more of a test of my ability to have put that in your head than it is of you in a weird way. There's no way for me to show that you know this stuff unless you show it in some way. So think of it like all the assignments you ever took, they're like scientific tests. They're assessments. It's like showing evidence that I actually did teach you the things that I taught you, or your English teacher actually did teach you the things that they're supposed to teach you. Now, we can't know that unless you turn the stuff in. And so the fact that I don't know means I'm not letting you move forward. You don't want to tread water on this with a bunch of 8th graders next year when you're freshmen. So get it done. It is not even hard.
And there's plenty of time, you guys. I mean, this whole competency model and you don't move on to the next thing until you're ready, and all of that can seem a little overwhelming. But Mr. Chester and I have a lot of experience in teaching science, and we know what the pace needs to be to get you through this curriculum in the 9 months that we have together. If you keep up with your assignments and turn them in the timelines we establish, we're professionals in setting those timelines. If you keep up with that timeline, you will finish with all the things that you need to know to be ready for the next level by the end of the year. If you habitually turn stuff in late, if you habitually procrastinate, if you end up in a situation like 90% of us are, where we're still working on Unit 1 as the rest of us are moving into Unit 2, then you're not going to get it done on the timeline. But we make the systems available to you so that you can do this and you can move on, and that you will be so much better prepared and so much more well-informed than any of your cohort groups at the other schools. But you have to take advantage of that, and you have to put trust and confidence into our expertise in this, because we really are experts in this system.
And on top of that, we're setting it up so that if you are moving faster, you will be able to move ahead. And the plan is, as far as you can go until you run out of the stuff in this book. If you can run all the way through this book, you're in great shape.
I challenge anybody in here to make me start writing biology curriculum before this year's out.
Yeah.
Because if you get there, if you're there at the end
Wait
of
a minute,
April,
don't listen to him, because he means I'll have.
I'll make Mr. Chester do it. But
Yeah.
if you finish physical science by the end of April, you start biology in May. You get to start on next year's stuff. You are
Right.
working ahead. You're
So
accelerating.
the exact reverse of the thing where you're stuck working on this if you didn't get it done, if you're ahead, then next year when we start biology, you're already ahead of everybody. And the goal is that you get more and more ahead, and that's how you can get an associate's degree here. But you can't do it by staying on the same pace as everybody else in Springdale or behind them. They don't give you extra degrees for that, guys. Yes?
Is biology 9th or 10th grade?
It's 9th for you. It's 10th in most schools. You can take if you have taken physical science as an 8th grader, you can take biology as a 9th grader.
Which is what
That's
all
all.
of you are taking.
Which is what all of you are taking.
You're all in physical science, which is a required high school graduation
This is
requirement.
an advanced school. Everybody cottoned on to that fact by now, right?
Yes.
Okay, so one thing I didn't realize is this.
Yeah, this is a 9th grade credit class, and I've said this many times. You have to pass physical science, this class, to graduate from high school. There's
Yes.
no getting around it. If you get an F because you don't turn anything in, you just keep doing this class. You cannot graduate high school by state law without this class. Those of you with 0% need to be processing that information.
And it doesn't matter if you leave here and go to a different school.
You got a what percent?
There were plenty of people who were 10th graders at Harvard, where I used to work, who had not passed physical science in the 9th grade, and they had to retake it as 10th graders. You must pass it. I'll show you the documentation that the state gives us that says you cannot get a high school diploma without this class.
It's in their student handbook.
This thing, for whatever reason, suddenly people just decided to turn it in. And so many of them did that I'm wondering if you just didn't fundamentally understand this assignment, and so you just gave up and didn't do it. First of all, that's not the right way to approach this. If you don't understand it, remember, there's zero penalty for turning it in. I will give you comments and give it back, and you can try again. There's no penalty. In fact, I prefer it that way. I don't want you to just turn in crap, but turn in your best effort, or write me and say, I don't understand what to do here, or come see me, or him. But I want to talk about this. I said several times, and I'm going to say it again, because you're going to see these over and over again, that understanding what this really says is most of your assignment. When
Yes.
you really understand what this says, you should be able to create a project pretty easily that will fulfill the assignment. To clear something up that people this morning didn't understand, this is not stuff we normally give to students. These are instructions to me to tell me what parts of the knowledge in my head I'm responsible for putting into yours. That's what that is. It's in a set of instructions that's telling me, the teacher, you have to make sure your students can do this. You have to make sure your students can do that. That's the reason it's not in super easy language. But here's the thing. One of the things that I can do with this brain and the experience that I have is read that and understand what it's saying. You should be able to do that too. It's one of the most powerful things you can be able to do. So you're going to practice it. You're going to get used to reading these. Because I'm not going to translate them for you. You're going to translate them. Now, I saw a lot of people attempt to do a translation in the following way. And we may have misled you on accident a little bit. I'm going to give you a better way. I'm going to give you better instruction on this. They copied this and they pasted it, and then they copied it again, and basically replaced some of the sciencey sounding words with other words that when they put the other words in there, it was clear that they didn't understand that word any better, because if they did, they would know that's the wrong word for that. That's not translating. That's trying to do the minimal effort to give me something that I'll give you a pass on. Here's the problem. My goal is that you can read this and understand it. If you can't do that, you can't do the project. So this is how I want you to approach this. And there are a bunch of you that haven't gotten this satisfactory on this yet. So I want you to go back to the drawing board. Start from scratch. And this is what I want you to do. Pretend that you have to teach this, you have to explain that to a 10-year-old, 8-year-old, okay? Your cousin in 5th grade. It shouldn't even look like this structure, okay? You don't have to sound sciencey. The goal is to not sound sciencey. Don't try to sound sciencey. The goal is explain this in such a way that you're giving me evidence that you actually understand what it's telling you to do. And if you already understand it, then that makes it easier. That's the first step. You have to understand it first to explain it to a 5th grader. So pretend you're trying to explain this to a 5th grader and write that down. Now, let me ask you this. 5th grader, would you say, apply Newton's third law? Would you say that to a 5th grader? What would you say, Dexter? Take that sentence in black and pretend I'm a 5th grader and tell me what to... Dexter, I don't understand this. I can kind of read it, but I don't understand it. Can you tell me what it means? You can't see that far. Pull it up on your Chromebook. Who can see this far and can explain it to me? Go ahead.
Oh, I didn't know I had to.
Shh. That doesn't mean anybody else starts talking. I'm a 5th grader. I don't understand what's applied. I don't understand. Tell me what that sentence in black means. Everybody else is quiet.
Show me a way, or show me what is Newton's third law.
I don't know what that is. Can you tell me about that? What's Newton's third law? What does that mean? Is it like the speeding? Don't speed?
No.
Okay. What does that mean? What?
Forgot the word.
Newton's first law is an object.
Third law.
Third law is an object has an equal to opposite reaction, so if you're on
An
a
object has an equal to opposite reaction. What do you mean?
So what if you jump on a trampoline and then whenever you jump, it pushes you up. So I guess that's what it looks like. I don't know.
What example has Mr. Chesser used in this class 1,000 times? Yes. Tell me about pushing the chairs. Get up and teach me Newton's third law. Get up and teach me Newton's third law. Everybody else is quiet.
Push it and pushes back on.
What do you mean? You mean it's like it's got muscles? It pushes back? I'm a 5th grader. Remember, I'm a 5th grader. It doesn't. A chair can't push anything. It doesn't have muscles or anything. Everybody else, quiet. What do you mean it pushes on you? What? I don't know what you mean it pushes back. It's hard, isn't it?
I can
Try it.
hold my eyes open.
Has anybody had me do this with them, by the way, when we were in a small group? Okay, show me and then I'll show you what I usually
So
do.
basically, what it means when he said every action has an equal and opposite reaction, it means with every action there is a result.
What do you mean by what do you mean by action?
Like, say you push this chair.
Okay, is that an action?
Yes, that is an action.
Okay, keep going.
What it means by when that is pushing back, it means that there's a force pushing back.
Like the Force, like from Star Wars?
Not saying no, even like this guy. There is a different force that pushes on your hand, not the force that is
Shh.
So when you push on this, there's a force pushing back because, like,
How do you know?
there's force
How do
back.
you know it's pushing back?
Because there is resistance.
Oh,
Because
what's
there's-
resistance? So wait a minute. Keep going. Everybody else quiet. You're doing great, by the way. Keep going.
Resistance is basically where there's something wanting to keep it from
You
being.
mean like I can feel it when I can feel it? Is that what you're talking about?
No.
No.
When the resistance is.
Welcome to my world, by the way.
A resistance is where there's something trying to keep you from moving. Like say there's a force of gravity going down, and the air molecules on this side of the
Okay.
that's pushing back this way. And there's something, those are stopping the chair from moving.
So like if it was in space, it wouldn't push back.
In space, there are still. So,
Okay, give him a hand. Look, first of all, let me clear up a couple of things. Even in space, the chair still has mass, and whether they're air molecules or not, when you push it, it pushes you back. Okay? This is what I usually do. Sit down in that chair. No. Put your foot on this chair. No, like you're going to push it. Now hold it. For every action, what's Newton's third law?
For every action,
And opposite. Everybody, lots of times people say or. Equal and opposite. Now, can you feel the chair? Why can you feel the chair? Okay? What are you feeling? Let's not use the chair. Put your foot up. Can you feel my hand?
Yeah.
What are you feeling? You feel me push back. Now I'm not pushing. You push me. Can you feel me? Can you feel my hand? Okay. Look. Show me an action and show me a reaction. Okay, the chair went that way and your foot went that way. That was the action. Was the chair going that way the reaction?
Yes.
Let me ask you something. Your foot went that way, the chair went that way. Is that way opposite of that way?
No.
It's the same. The force is what you feel. Okay. Have a seat. Thank you. Will you stay there? No, that's fine. Look. You're laughing, but how do you think I feel? I have to read this, and then I have to figure out, well, how am I going to explain that to them? This is what your teachers go through all the time. This is our job. Like, how am I going to make them understand this complicated thing? Okay? So you need to write down like that exercise. It's hard, right? Yeah, exactly. Stop laughing. Now you guys are all laughing, but none of you have done a better job, or very few of you have done a better job of translating this. So when you translate it, I don't want a word-for-word translation. What I want you to do is, maybe translate was the wrong way to explain it. I want you to explain to me what that's saying as if I'm a fifth grader, maybe not a fifth grader, but as if maybe a seventh grader or maybe an eighth grader who just doesn't know, one of your friends. And you have to tell me, like, if you say Newton's third law, and I go, I don't know what that is, and then you say for every action there's an equal but opposite reaction, and then I say, what does that mean? You have to explain that too. You have to explain all that stuff. The thing is that when you can explain all that, I haven't told you to put it up yet. You're looking around like, me? Who, me? If you can explain it really clearly, then I begin to have evidence that you know what I know, which is my goal, to teach you that stuff. Okay? So, you still owe that to me. And get good at that, because you're going to do that a lot from here on. In fact, that's going to be one of the major things you do. You're going to get to where, I bet, by the time you graduate this school, you'd be able to teach this subject, because you will have figured out how to understand